Hello everybody, welcome to the next session of the video series. Here in this time we'll be discussing next sort, quick sort. In this lecture I'll be telling you the basic technique how we can sort using quick sort recursively. So let us start with this. For any inquiry you can contact here at satyawanteacher@gmail.com. You can mail me if you have any query, or you can comment under this video when you need to ask any question. Okay, so let us start. Well, quick sort is basically based on divide and conquer policy. Here a list will be given, and to that list we'll be dividing into two parts first, and then we'll be keep on dividing the list into subparts. We'll see here throughout the lecture. Okay, I have written a very simple algorithm here. How we'll do this? We do the following 3 steps until the list is sorted. We'll repeat it. Step 1. Find the pivot that divide complete list into 2 parts. Okay. First of all, any array will be given to us, and that array will be divided into 2 parts. We will see in the next slides. Okay, step 2. Quick sort the first part, that is left side, that is on left side of the pivot. Third, quick sort the part of the list that is on the right side of the pivot. Okay. Note, we repeat the steps for left and right sides, considering them the individual lists. Okay, now how we'll do this? We'll come to this slide again and let us see how we will be doing this. Okay, practically suppose I have this as first iteration, and this is my list 11 to 9 13 57 up to 3. Okay, here we have discussed in last slide that we'll be taking a pivot. Well, 11 is taken as pivot. The pivot selection is of very important role in quick sort. Here basic belief of many of software algorithm developers is that the pivot is selected to be the first element of the list. Okay, so 11 here is selected to be pivot element. So what is strategy here is the list is to be separated into 2 groups like this way. Here I have shown that the 11 is the point here, and we'll make it to be in middle somewhere where all the elements on the left side of 11 will be smaller than 11, and all the elements on the right side of 11 will be greater than 11. This is what we have to do in first iteration. Okay, here in first iteration my pivot is fixed. What is meaning of pivot is fixed? I mean 11 is at right position when we will be doing sorting. So all the element on the left are smaller than 11, and all the element in the right side of pivot are greater than the pivot value. Okay, so this is first partition that will be taking in consideration on the next quick sort. This is second partition that will be taken as second consideration for sorting. Okay, in the last slide that was like this way. If we go some revert here, if we come here, then step 1, find the pivot that divides complete list into 2 parts. Okay, 11 was taken as pivot, and 11 was partitioning the list into 2 parts, one on the left side where all the elements were smaller than 11, one on the right side where all the elements were greater than 11. So first list considered is where all the elements are sorted on the left side, and second list is considered to be the right list. Okay, let us come to the point here this way. Okay, now next My next point of consideration is how we will be doing all the elements on the left to be smaller than this. How we will make the partition, okay, smaller element on the left side and larger. How we'll be doing the partition. Let us see this into the next slide, okay. So, okay, how to split an array into two halves. Here the list is given and we have settled these two pointers. After taking pivot, we have settled two pointers, one on the first element of the list and second on the last element of the list, okay. So here pivot is taken, selected, that is 11 on the next table representation. What we need to do is, while we'll be going on the right side of the list, we need to find element that is greater than the pivot element. Listen it very carefully. We need to find the element that is greater than this pivot value, okay. So 2, 9, 2 is smaller, then we'll proceed to 9, 9 is smaller, then we'll proceed to 13, 13 is greater than 11. So this was what we need to find and 13 is found. The next element we need to proceed here on this side, the rightmost side, that is the second anchor we have taken. Here on the right side we need to find the smaller element than the pivot value. This is again point of consideration to be careful. Here on the right side we have 3 and 3 is already smaller than 11, so this is our point of consideration. When we were moving on the right side of the list, we were to find the greater element. When we need to move on the left side of the list, we need to find the small element in the list. Okay, these two elements we have found. Now we need to interchange this, and elements are interchanged in the next step. Okay, 3 is taken here, you can see here 13 is there, and in this list 3 is there and 13 is taken as the last element. Okay, in the next part we will proceed on doing the same thing, that this pointer will be proceeding on the right side and this pointer will be keeping proceeding on the left side. This red pointer on the right side and blue pointer on the left side. On the right side we will be again finding the value that is greater than this pivot value. We always need to compare our values with the pivot value only. Okay, so next we proceed. 3 is smaller, okay, and 57 is greater. So what we will need to find, we were in search of, we have found that 57, and in the next step we need to find the smaller element. The smaller element is given here, 1 is smaller than 11. So on the next slide we will be interchanging these two values. Our point of consideration we have found, and these two values 57 and 1 will be interchanged. So you can see here on the next part 1 is taken here and 57 is taken here. Next we proceed. Again we need to proceed on the right side. 25 is again greater than 11, so we'll consider this to be point of consideration. And on the left side we need to find value smaller than this 1. Okay, here there is a main point, that up to what steps we need to find these 25, we need to find these values on the right side and to proceed on the and blue will proceed on the left side. Until or unless we cross these lines, we will find this, but we do not interchange them if this blue is on the left side and this red on the right side. We'll keep on finding the elements, okay, but we do not interchange them if these two have crossed each other. We'll see here 25 is the point of concentration. Well, we were going on the right side, and on the left side we keep on doing this on the left side, and here 25 is again the point, but we need to find the smaller element. Here on the right side we have already found 25 to be greater element, but here my blue arrow is proceeding on the left side of the 25. There is no problem at all, but here we will not interchange the values. Here we will not interchange the values. Which values? 1 and 25. Here my first iteration is going to be finished. Here we will now consider that my this anchor, blue anchor, has crossed the red anchor, and 1 is taken here. Now these two has been crossed. On the next step we'll do the main job. We will interchange the pivot value with this blue anchor. Okay, and here is the main pivot. Now you can see here that all the elements that are smaller than 11 are on the left side of 11, and position is fixed, and point of consideration for first partition is all the elements on the left side, and it is taken to be individual array, and second partition is taken as individual array. And when we will be doing further partitions, we will be finding the new pivots, and we will keep on fixing the value of these pivots until or unless my array size is left to be one element. Keep this in mind. This is to be repeated. The process, that the first iteration I have shown that I taken a pivot, then all the element on the left side of the pivot are smaller than the pivot, and all the element on the right side of the pivot are the greater ones. So these complete list is now divided into two parts. You can see here the first partition and the second partition. They are now taken to be the individual list. He will be making a function, and to this function in the next video I'm going to discuss the programming part. In that function I'll be passing the first partition as individual array and the next partition as in individual array. So we'll keep on doing this until or unless we are left with the one element or one element. Okay, so here is what we take to be the new pivot values, and one thing there that is important to be discussed here, that the pivot selection is the main concern in the quicksort. Quicksort is valuable when the pivot selection is done correctly. There are a lot many things to be discussed in this way. If you have any query, you can further contact to me, satyawanteacher@gmail.com, applied assistant professor, computer application, Pite College. Have a nice day. If you need to do any comments, if you need to ask anything, please feel free to do the same. And on the next lecture we'll be discussing how to write the algorithm and how to make the program for the quicksort. Have a nice time. Do subscribe my channel if you like it. Do subscribe my video if you like the same. Thank you very much.